You are watching Darasa Online.
Welcome once again. It's Darasa Online. My name is Mbarako Marabed, teaching advanced mathematics. We are still continuing with our revision. For those who are in Form 6, please join the lesson until the end. Our subject for revision is advanced mathematics. Advanced mathematics. The topic of revision is integration. The specific part is application of integration. Now, our main focus for today's lesson will be on how to find the area under given two curves. But I hope you remember, when you're finding area under one curve, we are having two cases. When the graph when the curve is drawn against the x-axis or horizontal axis, and when the curve is drawn against the vertical axis. The same case we are going to have when you are finding the area between the two curves. Now, let's check area between two curves. So as I said, in the case of one curve, we are having two cases, the case of horizontal axis and the case of vertical axis. Likewise, in the case of having two curves, we will be having the same case with the horizontal axis and with the vertical axis. Now, by starting with case number one. Case number one is when the graph is drawn or plotted against the horizontal axis. So we'll be having the following nature of the graph. So this is x-axis and that is y-axis, in which you'll be given two curves that you are supposed to show them in the xy axis before you continue with. So let's assume we have this curve, name it f of x, and another one that is in the bottom, call it g of x. So f of x and gx are the two given curves that you're supposed to find the area formed between the two curves, but in a specific limit that will be given in the question. So let's take our limit to be from A up to B. So this is the area that we are going to find, or we are going to look on it. How to find that area, I mean this area. Having two curves, f of x and that of g of x. It's very easy, my dear student. Don't worry. Now, how do we find area of such kind of question? There is a formula that is normally used. Remember, this is just a revision. We are looking on the first case. Case number one. Case number one, when the curve is drawn against the x-axis or horizontal axis. It means the given limit are found or are given in terms of x and not y. So if you see the given limit or the given value of integral that are supposed to find, the auto-evaluate, are given in terms of x, then that graph is drawn with the horizontal axis. Now area will be obtained by using the following formula. From A to B. A to B, these are the limit. If you look our graph here, we have from A up to B. We are looking for this area in between the two curves, f of x and that of g of x. Now the formula is this one. We normally say f of x minus g of x, then dx. But if you look clearly, here in our xy plane, we have two curves. F of x is in the upper case of the two graphs. So you can say, by saying from A to B of the upper function minus the lower function, then integrate with respect to x. So that is the formula that you are going to use in solving question involving area between the two curves. Now, if we have the first case that is with horizontal axis or x-axis. Now let's see the second case. What if we are given the curves that are drawn against the vertical axis? How the formula is going to look like? So let's take again. So this is in our second case. So the second case is when the curves are drawn against the vertical axis, or we call it y-axis. Against the vertical axis, which is the y-axis in xy plane. Now, let's assume this is our two curves that are drawn or sketched in xy plane. And the curves are of this nature. That is curve number one. We call it g of y. And we have the second one. Call this one f of y. There is a reason. Why are they defined as f of y and g of y? Because the limit that you'll be looking, they'll be from y-axis. Let's say this is point D, and this one to be point C. We are going to see on how to find this area. Now, if you look clearly here, we have two functions. We have f of y and we have g of y. F of y is in front of g of y. Or we can say this is to the right or forward of g of y. And this one is in the left side of f of y or in backward. Then how do we find the area of such kind of curve? So the area is obtained by taking the limit from C to D of the two functions f of y minus g of y, then dy. So that is the formula. Again, you can use the word right function minus left function. So we can say again, from C to D, here we take the right function that is in front of the other minus the left function, then dy. So these are the key formula that you are supposed to have them before going to any examination that is concerning with advanced mathematics. Now, after seeing or revising on how to write the formula, how to sketch the simple graph, now let's go to examples. Okay, now before we go to example, now let's remind again the steps that are supposed to be taken when finding area. The same step that I used to find the area under one curve. We are going to use the same steps when you're finding area under two curves. So the steps are as follows. So step number 1. This step are very important, my dear student, before starting doing the example. Now, as we said, we have steps. So these are the steps to be taken or to be followed. Now, step number 1 is to sketch the curve in XY plane. Sketch the two curves in XY plane. Why do we sketch the graph? So as to know which function is in the upper part and which one is in the lower case. So as you use the appropriate formula. So sketching is unavoidable. You are supposed to sketch the curves. Thereafter, after sketching the two curves, you are supposed to shade the region that is between, but by looking the given limit. So here we say again, shade the required region or the area that you asked to find from the question. Now, after shading, the next part now is to choose the appropriate formula by considering the two cases. If the curves are drawn against the x-axis, remember the formula. And if the curves are drawn against the vertical axis, remember again the formula. So the third step is to choose the appropriate formula. This depending on how the graph are sketched in the XY plane. If it is in the vertical, if it is with horizontal axis or x-axis, do you remember the formula? So the formula, as we said, it is a from the integral of a to b of the difference between the upper function and the lower function. Then you integrate. And if it's in the case with y-axis, the area is a, now let's say c to d, of again f of y, d, y, because it is against the y-axis. Now, my dear students, let's check examples on how to find the area between the two given curves. So, in example number 1, Roman 1. So the question normally comes like this one. Determine the area of the region enclosed by the curves below. So you'll be given two curves and asked to find the area enclosed by that curve. Now, for instance, here we are given f of x as x squared minus 1 as the first function, and g of x equal to x plus 1 as the second function. And we asked to find the area enclosed by the two curves. So how will you know the area enclosed without drawing the curve or sketching the curve? No way out, my dear. So you are supposed to sketch the graph. Okay, now let's see. Before going to sketch the graph, let's see. We can find the limit by solving, because f of x and g of x, these are sometimes defined as y, because this one are the two functions that are defined with the x. It means x is the independent variable, but y is the dependent variable. Now we can solve the two equations by equating x squared minus 1 and x plus 1. So as we see, which limit we are going to use them when finding the area. So here we are just equating x squared minus 1 is equal to x plus 1. Why are we doing so? Because the function are defined in terms of x. So we are finding the value of x. And these are going to be our limit in the integral. So if you rewrite it, will be x squared minus x minus 1 is equal to 0. So we have x squared minus x minus 2. Now this one is a quadratic equation. Take out your calculator, find the value of x. Now I'm taking out my calculator. We are going to solve the x squared minus x minus 2 equal to 0. So as we know the value of x, which will be our limit. Make sure you clear the mode before you start. So shift plus 3. Now my calculator is now ready to be used. Now again go to mode, press equation, and then take the degree one. Now we are plugging the coefficient of x squared and that of x and the constant one. So the coefficient of x squared is a, which is 1, and that of b is negative 1, and the constant one is negative 2. So in which, in my calculator, x number 1, or the first value of x, is equal to 2. And the second value of x is negative 1. So the second value of x is negative 1. So x equal to 2 and x equal to negative 1. These are the limit that will enclose the required area. That is the first step, my dear student. After knowing the value or the limit, now let's go and sketch so as we can see clearly this area that will be enclosed by 2 and that of negative 1. But how do you sketch the curve? You are supposed to remember a technique of using a table value. Now the same, we are going to use a table value so as we have the two functions. Now, because this function are drawing against the horizontal axis, so on top here we are going to write the x value in which we have the starting point. We know that there must be negative 1 and there must be also positive 2. So we start by, let's say, negative 2 and negative 1, 0, 1, and then we can add 2 and add 1 another, that is 3. Thereafter, writing the two functions as they are in the same table. Now starting with x plus 1. This is g of x. So this one is our g of x. Then f of x will be equal to x squared minus 1. Now we are starting to plug the value, filling the x plus 1 row. When x is negative 2, negative 2 plus 1, here we'll be having negative 1. When x is negative 1, negative 1 plus 1 will be having 0. When x is 0, here we'll be having positive 1. And when it is 1, it will be 2. When x is 2, will be equal to 3. And when x is equal to 3, we'll be having 4. That is in the case of g of x. Now let's check when in terms of f of x. So when we take 2, negative 2 square, we'll be having 4. 4 minus 1, we have 3. Again, taking negative 1. Negative 1 square is just 1. 1 minus 1 is 0. When we have 0, we'll be having negative 1. And when we'll be having 1, we'll be having 0. Having 2, it will be 2 squared, 4 minus 1, equal to 3. Let's check the last one, that is 3. 3 squared is 9 minus 1, it is 8. Now that is the table. Remember, this part has a mark in your examination. So do not skip any part of your solution. Let's sketch just a simple diagram. This is x, and that is y. This is the y-axis. We have 0, 1, 2, 3, let's say 4. Negative 1, negative 2, negative 3. That is in the case of x-axis, this value. Now let's go in the case of vertical value. We'll be having 1, 2, 3, 4. Again, here we'll be having negative 1, negative 2, negative 3. Because you will be given graph paper, go and sketch that curve in your graph paper. Now let's start plugging the value or transfer the point. When x is negative 2, our g of x is negative 1. When x is equal to negative 2, our g of x is negative 1. So we have a point here. Again, when x is equal to negative 1, g of x is equal to 0. That is the point. When x is equal to 0, our g of x is equal to 1. We have it over there. When x is equal to 1, our g of x is 2, like that one. And when x is equal to 2, we have 3. So from there, just join the point using ruler. And then name that this is g of x equal to x plus 1. Now let's check the second function, that is x squared minus 1, which is our f of x. So when x is negative 2, the value of f of x is positive 3. When x is equal to negative 2, our value of f of x is positive 3. So that point is somewhere there. Again, when x is negative 1, we have 0. When x is negative 1, we have 0. When x is equal to 0, we have negative 1. When x equal to 0, we have negative 1. When x equal to 1, we have 0. When x equal to 1, we have 0. Now let's see, when x is equal to 2, we have 3. When x equal to 2, we have 3. And then let's add another one. When x equal to 3, we have 8. So it will be somewhere there. Now again, join the points. Okay, after that, shade the region that is bounded between the two curves. So this is our region that we are supposed to find its area. So this is the required area. And do you see the limit here, or the value of x? We have x equal to 2 and x equal to negative 1. Again, checking here, it is from negative 1 up to positive 2 is where now the two curves are enclosed by that numbers, -1 and +2. Now, after sketching the graph, what next? So it means now you need to observe which function is in the upper case and which one is in the lower case. So if you look clearly here, g of x is the upper function and the f of x is the lower function. So this is our f of x equal to x squared minus 1. Now from there, choose now the appropriate formula to use. Now because the curves are drawn against the x-axis, horizontal axis, the formula we are going to use is this one. So area is equal to from A to B of the upper function minus the lower function dx. What is our upper function? Our upper function is g of x. So therefore area is given by the limit from A to B of g of x minus f of x dx. Because we know the function, let's go direct writing the function. It will be from A to B. Our g of x is x plus 1, and that of f of x is minus x squared minus 1. So simplifying, we'll be having from A to B of the integral. Now when you open the bracket, this one becomes x as it is plus 1, then minus x squared plus 1 dx. So the area will be equal to from A to B of negative x squared plus x plus 2 dx. But what is our limit? Here there is a trick. You cannot find the area from -1 up to +2 because in between we have 0. So we are supposed to stop when x is equal to 0. So taking that one. So our area will be equal to from -1 to 0 of the function negative x plus x, then plus 2 dx. That is up to 0. Again, you plus now from 0 up to 2. From 0 up to 2 of the function negative x plus negative x squared plus x plus 2 dx. Now we are going to deal with this, and at last we'll be having the area that is enclosed by the two curves. Now let's integrate. So if we integrate, we'll be having the following. So copying first because we don't have enough space. -1 to 0 of negative x squared plus x plus 2 dx. Then we'll be adding from 0 to 2 of negative x squared plus x plus 2 dx. Now let's integrate. So if we integrate this part, it's the same as distributing the integral within x squared plus x plus 2. So it will be, if you integrate, the same as taking negative out, then to the bracket of x cubed over 3. This one is from -1 to 0. Then we plus the second one, that is x. It will be x squared over 2 from -1 to 0. Then we plus 2 of x from -1 to 0. This is from the first part of the integral. Then we add the second integral part. Then we integrate again. We take negative out. So this negative here will be x cubed over 3. But the limit now is from 0 up to 2. So we take from 0 up to 2 we plus the second one, that is x. So it will be x squared over 2 from 0 to positive 2 plus the last one, that is 2 to the bracket of x from 0 to 2. Now it's time to substitute the limit and then you simplify. After simplifying the two parts, you add together, you'll be having the area that you are looking for. Now negative out, so we are substituting the value. Here we'll be having 0 over 3. Then we minus. This negative will be negative 1 to the power 3 over 3. Then we plus the second part, that is 0 over 2. We minus negative 1 square over 2. We plus 2 to the bracket of 0 minus negative 1. So that will be the value obtained in the first integral. Now in the second integral, we'll be having negative, this one will be equal to negative 8 over 3, because 2 power 3 is 80, and this negative make it to be negative 8 over 3. Then we plus 2 power 2 is 4, write 4 over 2. Lastly is 2 to the bracket. 2 power 2 is just a square. It is 4 minus 0, make it 4. Now from there, keep on simplifying. You'll be having negative. This one will be equal to 0. But here we'll be having negative 1, negative and negative. When they combine, they make it to be positive 1 over 3. Then plus again. This negative 1 square is positive. Then times negative. We'll be having negative 1 over 2. But negative become positive. So it is 2 times 1, we plus 2. That will be in that bracket. Now in that side of, we'll be having negative 8 over 3. That is 2 plus 80 will be plus 10. Okay, we are about to finish our question. So here we'll be having negative 1 over 3 because of this negative, and this one will be equal to negative 1 over 2, then plus 2. We add up with 10 minus 8 over 3. It's time now to use your calculator to simplify. So we take negative 1 over 3, we minus 1 over 2, and then we plus 2. We will be having 7 over 6. So again, if we take that part, it's 10 minus 80 over 3. The answer here is 22 over 3. Therefore, simplify to the last point, we plus 7 divided by 6, which give us 17 over 2. When you simplify and leave your answer in decimal, the same as taking 17 divided by 2, which is 80.5. But this one is just a number. Remember, we are finding the area. It must have unit. So here, you conclude by saying square units. And that is the area between the two curves that we are given in the question. Now, example number 2. Roman number 2. We are given x equal to y squared minus 1 and x equal to y plus 1. So this one, the function is defined in terms of y. We are given x equal to y square minus 1 and x equal to y plus 1. So it means this function is the same as writing f of y is equal to y square minus 1 and the g of y equal to y plus 1. Again, do the same as what we did in the first example. So find the value of y so as you know which area is going to enclose the two curves vertically. So we equate the two function. Equate the two function. So when we equate, we'll be having y square minus 1 equal to y plus 1. So it is y square minus y minus 1 minus 1 is equal to 0. So y square minus y is minus 2 is equal to 0. So that is our quadratic. Again, use the same technique. Use your calculator, go to equation, substitute the coefficient of y square in that of y and the constant. You will obtain the value of y is equal to negative 1 and the other one will be equal to positive 2. After having this value, go and draw the table value. Now our table value will be written now in terms of y. So here we are going to say this is y, but we have negative number here. So we can start from negative 2, again negative 1, 0, 1, 2, and let's say 3. Now our function here, we have y square minus 1, and the other one is y plus 1, in which y square is equal to f of y, and this is g of y. Now let's start plug. So when we take negative 2 and plug here, what are we going to get? Will be positive 4 minus 1 will be 3. When it's negative 1, we'll be having 0. When it is 0, we'll be having negative 1. And when we have positive 1, it will be 0, because 1 squared is 1 minus 1 is 0. When it is 2, it will be 4 minus 1, that is 3. Then when it is 3, it will be 9. 9 minus 1 is equal to 8. Again, go for the case of y plus 1. For the case of y plus 1, it's negative 2 plus 1, we get negative 1. When negative 1 plus 1 is equal to 0, when it is equal to 0, here we'll be having positive 1. And when we have 1, here will be equal to 0. And when it's equal to 2 is 2 plus 1, then we have 3. And when it's 3, we'll be having 4. After filling the table value, let's go now to plot and see where the graph will be seen. Now sketching the curves. So remember now, these are the value of y. So we have 0, 1, 2, 3, 4. So these are the y value. And this will be the value of f of y, which is the same as taking the x-axis. So here is negative 1, negative 2, negative 3. Now, let's check again in this side. We have up to positive 8. So we say here we have 1, 2, 3, 4, 5. Then 8 will be somewhere there. negative 1, negative 2, negative 3, negative 4. Now let's transfer one point after another. So when y is negative 2, the y square or the f of y is equal to 3. So when it is negative 2, we have the point there. When it is negative 1, the value is 0. When it is 1, we have 0. When it is 1, we have 0. When it is 0, we have negative 1 somewhere there. And when we have 2, we have 3. So 3 is somewhere there. When we have 1, we have 0. And when we have 2, we have 3. When we have 3, we have 8. So 80 is somewhere there. Now join the point. So you'll be having and this one is, this is f of y. That is y squared minus 1. Now let's go for the second one. When negative 2 give us negative 1, when negative 2 give us negative 1, when negative 1 give us 0, negative 1 give us 0, when it's 0 give us positive 1, so positive 1, and when it is 1 give us 0, when it is 2 give us 3, when it 2 give 3. Again, when equal to 3, we have 4. So equal to 3, we have 4. Now join the point. So this is the area that we are supposed to find or to determine. This is the area. And this function is the g of y, that is y plus 1. Now the area is from negative 1 to positive 2. So this is the area that we are going to calculate. Now after sketching the curve, now it's time to choose the appropriate formula by looking which function is to the right and which one is to the left. Now g of y is in front of f of y. So again, so the formula will be equal to area from C to D of g of y minus f of y, then dy. So that is the formula that we are going to use. But our difference between the two functions is this one, from C to D. Now let's find the difference, then you are going to substitute directly. We have y plus 1 minus y squared minus 1, then dy. This is from C to D of y plus 2, then minus y squared dy. So that is our function, or the difference between the two. Now again, looking vertically, we have from negative 1 up to positive 2. You cannot find the area directly from negative number to positive number. Here you are supposed to break down from negative 1 to 0, and then from 0 up to 2, like this one. So the area will be equal to from negative 1 to 0 of our function y plus 2 minus y square dy, then from 0 to positive 2 of the function y plus 2 minus y square dy. Now it's time to integrate and substitute the limit. Then lastly, simplify. Now starting with the first one, here we'll be having y square over 2 from negative 1 to 0 plus 2y from negative 1 to 0. Then we minus y to the power of 3 over 3 from negative 1 to 0. This is the first part. Now let's go for the second part. We'll be having plus. So here will be y square over 2 from 0 to 2 plus 2y from 0 to 2. And the last one will be equal to minus y to the power of 3 over 3 from 0 to 2. Then from there, it's time now to substitute the limit. Starting with the first part. When it's 0, here becomes 0 minus negative 1 become 1 over 2. We plus 2 bracket 0 minus negative 1. Then we minus, it is 0 minus again negative 1 over 3. Then you are going to plus. So if we plus, that one will be equal to 4 over 2 plus 2 bracket 2 power 2 is just 4. Then minus. That one is 80 over 3. Then to that point, keep on simplifying. This one will be equal to negative 1 over 2. This one become positive, then plus 2. Again, this one is positive, but this one is negative. So it's negative 1 over 3. We are going to plus. So if we plus, this one become positive 2, and this one become 80, so it is 10 minus 80 over 3. So if we simplify to the last point, what we are going to get? Use your calculator, simplify. So we have negative 1 over 2 plus 2 minus 1 over 3. Here we have 7 over 6 plus 10 minus 80 over 3, which is 22 over 3. Now simplify by adding 7 over 6. We have 17 over 2, which when you divide, you'll ending having 80.5 square unit. So that is how to find the area under two curves. So what I'm trying to emphasize to you, remember all the steps that you're supposed to undertake when you're finding the area, either area under one curve or area under two curves. So the step that of sketching the graph, shading the area, and then choose the appropriate formula is very important, my dear student. To that point, now it's time to you to take question for more practice. Okay, question for more practice. Question number 1. Prove that the area between the curves x equal to y plus 1 and the x-axis between x equal to 0 and x equal to 0 is 1 square unit. So if you see this question is the area under one curve, that is x equal to y plus 1. You're supposed to prove that you get 1 unity square. But the second question, sketch and find the area enclosed between the two curves, x squared plus y minus 5 equal to 0, and x squared minus y minus 3 is equal to 0. That's the second question. Last question is y squared equal to 2x and x squared is equal to 2y. So these are the questions that you are supposed to take them and work on them. To that point, my lesson ends up here. Do not miss the next lesson.